time.
All right, so the next speaker, Bryan Helmkamp. I felt like I've known Bryan a very long time, but technically, and we chatted about this, when did we first meet for the first time? It was only a couple of years ago, but when Ruby and Rails sort of came out, there was this secret club called Caboose. And it came about because as Rails became popular, the IRC channel, the Ruby on Rails IRC channel became filled with people that didn't know anything, which is exactly what you actually want when you're starting a new community, because that's a healthy thing. New people coming in, you've got people that teach the new people the basics, so they stop being new, and those people then turn around and help the new people, and that's a healthy community. But what you get is the people that know a lot get tired of explaining how to install Ruby, get tired of answering how the router works, and tired of that. And they just want to go off and be alone. And so they did this. And then you became aspirational. You came to the Ruby community and you heard about Caboose and its mysterious ways and its secret rules. I don't know if they weren't secret rules. And so it was kind of aspirational. If you became interesting enough, someone might invite you into Caboose. And so Bryan and I met through that. And many years later, Bryan came up with this. He did consulting like many of us, and eventually came up with an idea. And the idea was to actually make it programmatically possible to determine code quality. And so he created a tool called Code Climate. That's his company. And to talk around the topic, please put your hands together for Bryan Helmkamp.
All right, shake hands. All right. So the last time that Nick and I were on the same stage, it was in New York, and it was reversed, and I was introducing him. And he actually had me do it 3 times because he didn't feel the first 2 were good enough, but I'm not going to put him through the same thing, and he just ran away because he probably expected that. So yeah, today we're going to be talking about building a culture of code quality. As Nick said, I started a company called Code Climate. Just so I know, how many people here have heard of Code Climate? Awesome. Cool. That's great. So there's a bit of a trick that you were involved in. You were probably told that you were going to get a full day of Ruby talks. But in fact, there's actually no Ruby code in this talk at all. In fact, there's no code of any kind in this talk at all. So just to prepare you for that, that's my disclaimer up at the beginning. However, hopefully there are some really practical practices and approaches that you can bring back to your work that will make your life a little bit better, as well as the life of your teammates a little bit better come Monday, which is tomorrow. So you can put this stuff right to work tomorrow. I want to begin with a definition of presenting problem. This is a medical term, and it refers to the initial symptom that causes you to consult a doctor. So you might have an experience that you're having pain in your knee. You don't really know why that is, but you go to the doctor and say, "Doctor, my knee hurts." And there could be any number of things that are causing that. And the doctor is going to try to diagnose that and figure out what's actually going on under the hood. With software, if you have low software quality, there are a number of presenting problems that you might start to experience within your organization and your team. The most common is slow progress. So have you ever had this experience where it feels like you have to fight with your code to get anything done? Any feature is going to be a struggle, and you know that there's this group of files. It's probably user RB. It's pretty much always user RB, that if you open it, you know, you're going to be in there all day. The callbacks are going to start doing crazy things, and emails and tweets are going to be going out when all you really want to do is set a default value. And it can make it start to feel like everything's a struggle and you can't get anything done. And programmers don't like this, right? Another presenting problem is bugs. Being from New York, this one is near and dear to my heart. Although we've also seen some great ones in Spain. The idea that you might have unintended consequences of the changes that you're making to your code. So you go to add a feature and something breaks. It's that simple, right? But the next step can be even worse, which is that when you go to fix one of those bugs, you might be creating new bugs in another part of the system. So you go over here and fix this one, and then you have to, oh, this spring sort of flies out over here, and you got to go over there and fix that. And eventually, you hit it enough times, and then you run away, right, so that the next guy can deal with whatever problems you didn't find. That's the system of whack-a-mole that you might experience if you have low code quality. And this can create a bit of a vicious cycle. It usually starts with pressure. So for whatever reason, the organization might have work that needs to be done, and there might be a fixed amount of time to do it, and there's never enough time, right? So maybe your software is going to be used at an event, at like a conference, and they're not going to reschedule that conference because your software is not ready. Your software has to be ready. There are healthy kinds of pressure and unhealthy kinds of pressure, but nonetheless, eventually pressure starts to be put on the development team. The problem is that developers write the worst code when they're under a deadline. And this is what I call slop. I'll draw a distinction here between technical debt and slop. Slop is just bad code. It wasn't some sort of strategic decision that you made to sort of delay working on something. It's just crappy code. So the pressure leads to crappy code. But as we know, crappy code leads to being late. That was that slow progress that we saw a minute ago. It's much more difficult to meet your goals when you're feeling like you're fighting with your code base all the time. And then being late leads to more pressure. So you really end up very quickly in this direct cycle where you're under all this pressure from the organization, there's crappy code being written, you don't feel like you can break out of it, it's just gotta be like this. And I don't even know what I'm gonna do, right? And this really sucks. This can be a very emotionally draining experience if you've ever had the experience of working on a team that was stuck in one of these cycles. This is what we're gonna look at today and how we can turn this around into the opposite by the end. So why does this happen? I like to say that the natural trajectory for a software project's quality is down. What's going on there? I think there's a few things that you can call out. One of them is changes to the business. So a lot of us work in startups, or we work at consultancies that work with startups. Maybe we just work in a small group inside of a much larger organization. But in all those situations, it might not be clear exactly how this software is going to deliver its value and how it's going to make an organization money at the time that you start. You're evolving your understanding of that as you're going, and that's going to put strain on the code base as the direction shifts from one thing to another. And sometimes you hear developers complaining, it feels like the business owners change their mind all the times. That's one problem. Another is we're in a period of a lot of technology changes, right? In order to scale things out far, we might need to replace a MySQL database with a NoSQL solution. And the ripple effects of that sort of architecture change can introduce technical debt in sloppy areas of your code base. And I've certainly seen this before. And finally, with a project that's been around for enough time, you've almost certainly undergone changes to the team. It may be as simple that you've added a junior developer to the team. You may have had somebody move on to another project or another organization. And the people who are coming on to the team might not have as much experience as the people who originally wrote the software. And they certainly don't have the knowledge of all of the design decisions and discussions that went into why the software is as it is today. So you're going to have to do something to level those people up, otherwise you're going to have to suffer the consequences. So this is a really interesting diagram that a guy named David Peterson drew up, and very few people have seen it, and I really love it, so I want to dig into it and spend a little bit of time with it. What he's trying to do is figure out at the code level, why does bad code happen? Why do projects become more complex over time? And if you start at the beginning, there's two reasonable assumptions: that developers don't want to introduce bugs. I don't think anyone here wants to introduce bugs. And we instinctively know that it's easy to introduce a bug when we're changing our code, right? So this is one reason that duplication can happen. We say, we don't want to change the code, so we'll just take this code and replicate it, and then I'll make my changes over here, and then I know I'm not introducing any bugs into the first piece, right? So we add duplication. The other thing that we might do is introduce conditional logic. We say, OK, well, this works great. All I need is in this specific case, I just need to do something slightly differently. So just wrap some conditionals around it. And that's a way to try to avoid introducing too much change. But if you combine these together, you start adding duplication and conditional logic itself can be difficult to understand. The code becomes complex more and more. And if the code is complex, it's difficult to understand the ramifications of any change you're about to make to it. And this very directly feeds into the beginning of the cycle, where it's difficult to understand what change you're about to make, and it goes on. And duplication and conditional logic keep sort of becoming pervasive through the code base. And what you end up with is legacy code. So there are a lot of definitions for legacy code. I'm going to present mine to you. It's a noun. Legacy code means code written by somebody else or code written by you more than 2 weeks ago. And that's what you might end up with. So Einstein said insanity is doing the same thing over and over again and expecting different results. And I feel like this is the trap that many of us are stuck in. This is what I'm going to try to shake you out of today. is everybody feels like the last project didn't go well. It was fine at the beginning, everything was great on day one, but somehow it ended up in the ditch. It ended up that it was difficult to maintain, and nobody wants to work on that. Let's leave that one behind, and let's go over here to this shiny new project. But then you say, okay, well, how are you going to do that differently? Like, what's going to change? I like to say hope is not a plan. Just because you want it to be different this time does not mean it's going to turn out differently. Sure, it's going to start better because you don't have all of that legacy code, but after 2 years, is the project going to be in a fundamentally different place than the project you just abandoned that was 2 years old? That's what we're going to work on today. So let's start with the universal solution to fixing any problem. You can kind of apply this in business and in life. There's exactly 2 steps that I like to apply. Gather information, and then act on the information that you gather. So if we're looking at the problem of low software quality, how can we gather information about what might be going on in your organization that's causing that? I like to split information into both qualitative and quantitative and start with the qualitative. So to begin, these are not revolutionary ideas, but if you have low software quality, this is something that should be coming up in your one-on-one discussions with your manager or your direct reports if you are a manager. Ask questions about how does it feel to work in the code base? Does it feel like the code is getting better or worse over time? And see what comes up. See what forces the engineers on the team describe as impacting their work. And you can do this also as a team with retrospective. So this is probably the biggest thing when people come to me and say, Bryan, we're having issues with our software development process. I say, let's make sure you have retrospectives in place. Because if everything else goes to hell, at least if you have retrospectives, you have a meeting to say, everything went to hell. And then you can try to fix that. So talk about the things that went right, things that went wrong, what are the drivers for those, and what you can do about improving your process as part of your data gathering process. And then we get to quantitative data, which I love. All of us programmers, we love quantitative data, maybe too much in some cases. But you can collect process metrics. If you use Pivotal Tracker, it's going to automatically tell you what your velocity is, even though I hate that term. If you use lean processes, it can tell you, you can measure what your lead time is or your cycle time is. You can survey your team. So I think we've all had this experience where there's a deadline looming, and nobody is saying what everyone is thinking, which is that there's no chance we're going to hit that. Because there's all this social pressure to not be the guy who says we're not going to hit that deadline. Now you're a contrarian and you're a stick in the mud, and the business guys hate you because you're the one who torpedoed their perfectly laid plan. Next time that happens, why don't you try this? Send an anonymous survey to everyone who's involved in the software creation process, asking them to rate between 1 and 5 how likely it is that the deadline is going to be met. Anonymously. And take the data that comes back and use that to have a conversation. You're probably going to get a much more accurate look at how likely your project is that it's on track. And then you can have a discussion about it, because now nobody's kind of throwing that out there. Also, near and dear to my heart, software metrics. So CodeClimate is a software metrics tool, but there are lots of tools to do this, especially in the Ruby community. It has a really rich ecosystem of tools that can look at your source code and give you information about what's going on. With these tools, you can start to get a high-level picture of the quality of this project as compared to other projects and how it's trending over time. And that's something you can bring into your discussion and talk with your team. Are these metrics sort of moving in the right direction? Do we believe in them? So you say, OK, Bryan, I've gone through the process of gathering the information, and I see how we've got these issues. What do we do to fix it? Right? Just give me the solution. So we'll look at how to do that. The first thing to note, though, is, of course, there's no silver bullets. Everybody has been looking for silver bullets with respect to software quality for a long, long time, and they just don't exist. It's not that you just need to change one thing or fire one person or start using one tool and all your problems are going to go away. It's never that simple. If it was that simple, we would all get paid a lot less. So this is a good thing. But there's a two-prong approach you can apply on any project in order to improve the quality. The first is to do no harm. So when people come to me and they say, Bryan, my software project is just a mess. It's impossible to get anything done. We know we have all of this technical debt and untested code. It's just a big disaster. What do I do? I say, OK, well, what are you doing about it? And as the conversation continues, most of the time, what I've realized is not only do these people have pre-existing conditions of software quality issues, they're also contributing and adding to those software quality issues every single day. Because they feel like they have a problem, they don't feel like they can do anything, they just keep doing what they've been doing. and they're introducing more duplication, more conditional logic, more unnecessary complexity every day, and they haven't even stopped. So it's like the old adage, what do you do when you find yourself in a hole? Stop digging, right? Don't introduce any more crappy code. And so then what do you do about the stuff that already exists? In this case, I like to employ the Boy Scout rule. And the Boy Scout rule is always leave your campsite in better condition than you found it. Now, to apply that to code, that means every time you make a change to your application, improve just one thing, even if that thing you're improving is not necessarily required in order to finish the work that you're trying to complete. It could just be reformatting a block of code, renaming a method that is a bit unclear in its name, splitting something in half, splitting a method in half. If you just do little changes like that, they'll add up over time. And in fact, if you follow both of these principles, if you introduce no more crappy code, and every time you change your code base, you make things a little bit better, there's only one direction your code quality can go, right? It can only go up. Now, there's a question of how quickly it will go up, but it can't get worse. It's just not possible. So that's a great solution, right? It's perfectly within our hands to do these two things, and then we have solved the problem for our existing project. Unfortunately, applying both of those principles is not necessarily trivial, right? People kind of intuitively know this. I shouldn't be introducing more bad code. I should be cleaning up things as I go along. But it just doesn't happen regularly enough for the actual results to be produced in all cases. So the rest of the talk is going to look at some specific practices. I call it kind of a quality playbook that you can apply with your team to give you the best shot at ceasing to introduce new code quality problems and then fixing ones as you go. OK. So one of the first things that you're probably going to find is that you're discovering problems too late in your process. It might be the case that you kind of had this discussion, said, OK, we're going to start coding better. And a couple weeks down the road, you look at something that was just written a couple weeks prior, and maybe it's still missing a bunch of tests. The test coverage just isn't there. You say, oh, man, what am I going to do about this? So what are my options at that point? There's no good option. You can either leave it, and now you have this untested code that you're going to be dragging around forever, or you can stop everything and go back and add tests for it. But at this point, it's 2 weeks later. You're already going to be working on some new feature, right? So what you really want to do is find a problem as soon as that problem is introduced, and then react to it as part of your day-to-day process, and not be surprised by it weeks or months down the road when you take a critical look at it. So you do this by setting up early warning systems, is what I recommend. Automate things, right? We're developers. We love automation. And you probably have this already in the form of a build failure. A build failure is really just a software quality defect. It's saying that the software that you've written doesn't match the specification and the documentation that the build is providing of what it's supposed to do. But you can do this for a lot more than just build failures. With things like static analysis, you can get alerts if you're introducing likely bugs or quality issues in your code base. If you have classes which are growing to the point where they're likely to be difficult to understand, you can have something notify you about that. If you have performance issues, New Relic can shoot you an email if your AppDex score drops by too much. And these days, you can even use dynamic and static testing tools to identify things like security vulnerabilities as soon as they're introduced into your code base, before they go out on production. If you add a cross-site scripting vulnerability, your team can be alerted about that and then fix it right away, improving the quality as you go with a much tighter feedback loop. So this is an example of a team receiving in HipChat notifications of likely security vulnerabilities that were introduced into their code base. This is something that CodeClimate can do, but you can wire up these tools yourself. There's a great tool called Brakeman that can do this for security. You have Flog and Flay for static analysis. All of these things, I try to get them all wired into a system where anytime something goes out of line, the team becomes aware of it right away. OK, so you're finding out about problems now sooner, but not everyone on the team is comfortable tackling them. And this can happen, right? We have to acknowledge that most of us would love to work on a team of only senior software engineers, but very few of us actually do. And we have to be cognizant of the different skill levels and knowledge levels within our team and work actively to level people up, right? So yesterday, there was some discussion about, well, how do you teach people how to refactor using patterns appropriately? And the answer was pair programming. So actually, I have to take a survey. How many people here pair program in front of one computer more than 4 hours a day where they work? I would say that's less than 5%. So pair programming is really interesting because everybody talks about it, but nobody does it. And I don't do it either. But I recommend it to people, so now I'm part of the problem. But there are other things that you can do in addition to pair programming, or in some cases instead of pair programming, to give you a shot at leveling your team up. One thing I suggest, not revolutionary, is a lunch and learn session, right? We're in a really fortunate place where all of the content that's being produced about how to design systems and objects and architect things is being put out for free in ways that we can consume it. So all of the talks for this conference and most other conferences are being recorded. There's a lot of great books and articles, blog posts that are out there, both new and old, that are covering the same types of software design problems that you're running into. Take some time with your team to sit down over lunch, get a pizza, watch a video, read an article, and then have a discussion about how it relates to the work that you're doing and the problems and stresses that you felt on your code base. And from those discussions, everyone's going to get better at what they do and is going to be more well-equipped to manage complexity going into the future. You can rotate the format of these sessions and also rotate the lead so that everybody in your team is taking a part of the responsibility for improving the team as a whole. Even the most junior developer on your team can pick out an interesting article and facilitate a discussion about it, even if they don't have all the answers. So the other technique I recommend for improving your team's ability to refactor is something I've coined as team factoring. And it's really just a group refactoring session. This is like extreme pair programming. You might have one person at a computer projecting onto a monitor, and 4 other people, the whole rest of the team working with them, to refactor a piece of code. So you pick out one piece of code in your app that's known to be problematic, and you sit down and you try to refactor it as a group. You spend an hour working together. Now, the value here is not in the actual improvement to the code. You're probably not going to be able to improve the code that much. It's not a very effective way to work. Otherwise, we would all be quad programming all the time. But the value is in the discussions. So you might have a senior person on your team say things like, well, we actually have tried 3 different ways of dealing with this problem, and here's what worked and what didn't work on each of them. Or you might have a junior person looking at a piece of code and saying, hey, what actually is the best practice that we're trying to follow with respect to testing strategy for this sort of code? And so at the end of it, you're probably not going to have something ready to ship. I recommend just tossing it out, don't worry about it, because the value is in the conversations. And you're going to distribute knowledge through your team in a much more active way. And again, you can rotate the focus, so you can work on a controller one week, a model the next week, a view the week after that, and you can rotate the lead, because even the junior programmers are able to contribute to this sort of process. OK, so you've tried to level up your team's refactoring ability, you've got early warning systems, and there's still bad code creeping in. What are you going to do, right? So some would say pair program, but I think for a lot of teams, that's a tough pill to swallow, even though I recommend it in many cases. So I wanted to give you something else that you can use if you're not in a position to pair program, or even if you are, that might be able to just really proactively address this code quality problem. And that's code reviews. Now, code reviews, I think, have a very poor reputation in the Ruby community. This is what most Rubyists think of when they hear code review. So this is an XKCD. It can be a bit hard to read, but on the left side, you've got a good code review going on with a minimal amount of swearing. And on the right side, you have a bad code review on, and it's just all sorts of F-bombs and cursing. And nobody really wants to be on the other side of these doors, not the reviewer or the person whose code is being reviewed. This doesn't look like a pleasant experience for anybody. But when I say formal code review, I think this is what most people are thinking of. So this guy, Frank Luntz, is an American. He is a Republican political strategist, and his job is to take things that don't sound good and come up with different words for the same thing that sound better. So that's actually his job. So in this case, he would say we're making a language error when we use the term formal code review. Formal code review is something Java people do. Sorry, Charlie. Java, it's terrible and slow and stodgy. So we can just tweak it a little bit. Instead of formal code review, I want you to, when you go back to work and say you want to do this, don't say you want to do formal code reviews at your job. That's the quickest way to end up out on your butt at any startup. Oh, we should just formally review all of our code. Not a good idea. GitHub pull requests. See, GitHub tricked us all into coding like Java programmers. You can tweet that. So for painless code review, I think there's a few keys that you want to adopt in your process. Make it non-blocking. So if you're about to have work that's being reviewed, make sure that you can continue to work on whatever you're working on without having to stop everything and wait for the review to happen. Make it asynchronous. at least to start, so that the reviewer can process it on their own time. You don't have to have people sitting in front of the same computer for every single review, although that can be a really nice way to have design discussions about something that get flagged in an initial asynchronous review. And make it opt-in. Trust your developers. Don't set policies that you need to review everything. Trust your developers to understand the size and the importance of the changes that they're making and decide which pieces of code are important enough to submit for review. And then treat that as a lever that you can tweak in your process going forward. You can review more code, you can review less code, depending on how things are going. Are you getting the results in terms of quality or whatever else you're setting out to do, knowledge sharing, that you want from your system, and then adjust accordingly? And the reason this is so important is that you can't edit your own writing. So I've written some blog posts. I've been fortunate enough to have some writing that's made its way into books. I've also edited a lot of blog posts and articles for other people. And the experience you have with those different processes is very different. When I have written something, whether it's code or an article, I am so emotionally connected to the process that was involved in creating that work that I can't disconnect from that. I know about all the dead ends that didn't pan out, all of the little discussion points and tweaks that were made to sort of get it exactly where it is, and it's very difficult to just like turn that off in your brain. But that's why a fresh set of eyes can be so valuable, and I think the same thing applies to code. And this is actually one reason why I've gone so far as to suggest using pull requests for code that was pair programmed, because both of the people in the pair kind of had that same author relationship to the work, but that's a subject for another day. So when you're reviewing, what do you look for? There's some basics. You want to make sure hopefully the programmer who's writing it made sure that the formatting is correct, that the code is correct and verified by tests. So as a reviewer, you shouldn't have to worry about that too much. Does it scale? Hopefully that's probably another thing that the original author did, maybe verifying it with some performance tests or load testing that, okay, it's going to meet the characteristics it needs to. Is it secure? Interestingly, most security issues are found by somebody who's looking at code and saying, that doesn't look quite right. That's how security issues get found. And by submitting your code into a pull request process, you're going to be much more likely to find that. But the big one is for comprehension. Did the person who had no involvement in the creating of the code, can they understand that piece of code? Do the names make sense, right? We talked about Kent Beck's rules for simple design. Is it comprehensible? Do I know what's going on? Do the abstractions seem right? This is kind of the hardest part of programming, and it's also the most important thing I think that you can review for. So now you might be thinking, hey, this sounds great, Brian. I'd love to do all this stuff starting tomorrow in my job. But some of you might be thinking about that one guy, right, back at your office. You know that guy who kind of feels like everything's just fine. Why do we need to change anything? I'm cool, dude. Like, I'm just here doing my thing. Let's not rock the boat, add any extra processes. Have you ever worked with somebody like that? So sometimes people ask me, well, how do you deal with that case of an individual who's resistant to process improvements? I think there's kind of two paths, one much more preferred than the other. The preferred way to deal with this is I would approach process changes as experiments. And not just like, oh, I'm going to say this is an experiment, but really I know it's going to work, so it's just a fake experiment. Like a real experiment. Try some of these ideas. They don't work for every team, and see how they work on your team. Hopefully you're going to demonstrate progress. You're going to get this feeling that things are moving better and quicker and faster with better results than they were before. And if you can demonstrate that progress, hopefully that individual will see that as well. And then over time, they're going to buy into the idea that maybe we can do better than we're doing right now. Now, that doesn't happen if you can't sort of get any traction at all in terms of getting started. You might need to part ways with that individual, and it might be a better fit for that individual at a different organization. Now, the other case, which is kind of more depressing, is you're thinking, if I bring this back at work, basically everybody's going to kill me. Like the project managers are going to hate it. All of the developers are going to hate it. The entire organization and institution is going to be resistant to the idea that we need to improve code quality. So what do I do in that case? And I think the phrase is change your organization or change your organization. In the first case, you become the agent of change within your organization. And in the second case, you quit and find a better employer. Which might be the best solution. So to wrap up, we saw a vicious cycle earlier, and what can happen if you start to implement these processes and get your code quality improving over time? How is it different? Well, it starts with quality code. But quality code creates satisfaction in developers. We feel better when we're doing that. Satisfaction leads to engagement. We're more connected to the work that we're doing, and that increases the sense of responsibility that we have for the work that we're putting out, and responsibility drives quality. So you can take that vicious cycle and start to replace it with a virtuous cycle where quality, satisfaction, engagement, and responsibility are working hand in hand, moving your project forward and improving your team and your code base together. And over time, if you stop introducing crappy code and you improve code as you go back to your code base and make changes, you have this process where you create sustainable progress, moving your project forward, and leaving everyone in a happier place. That's all I've got. Thank you very much for your time and attention.
Hi. You talked a lot about refactoring and the progressive enhancement. How do you take a big project you have with no tests at all? How can you approach refactoring to that without fear of changing?
Yeah. So the question is, how do you approach a big project with no test coverage at all and be able to refactor without fear of breaking everything? Is that right? Yeah. So the technique that I like the most is to just figure out how to beat the code into submission to wrap a high-level sort of smoke test or regression test around a really large unit. So you can use something like Capybara, and it doesn't really matter what the code looks like under the hood. You might have to manage some external dependencies, but ideally you can create a small set of tests that verify that the application, the standard that I like is the application works well enough so that if I ship it, I'm not going to be woken up in the middle of the night. And there's usually only a handful of things that any app needs to do to be good enough that you don't need to get woken up in the middle of the night. Write the tests for those. There's probably 5 of them or something like that. They can be full stack tests. Run those regularly. It's going to slow down your cycle of refactoring because they're going to take a bunch of time to run. That's why you want to limit the number of them. But that's where I would start, and then start TDDing new code so that as you're creating new areas of the system, they're in a better spot to be refactored individually.
That's brilliant. I like the idea of sleep-driven development.
So how do you use Code Climate for developing Code Climate? And what's your Code Climate score on Code Climate?
That's very meta. Yes. So how do we use Code Climate to develop Code Climate? Yeah, so Code Climate is self-aware, which I feel like is an important achievement that every developer needs to reach at some point in their career, is write something in itself for that kind of thing, right? Which is a little crazy. But we use it the same way that we recommend our customers use it, which is primarily to surface problems and be, like I said, one of these early warning systems. So it rates every class from A to F. If we have classes that are a D or an F, that's going to be something that we want to respond to right away. We don't want to introduce new Ds or Fs. That's kind of the main way that we use it on the code quality side. It also does security stuff, but I won't talk about that. The Code Climate score for Code Climate, I think, is 3.2, but I've been in Spain a week, and it might have dropped because my coworkers may have introduced some other code. They'll never see this video. Seriously, they already hear me talk too much.
If you make code review non-blocking, how do you ensure that it ends up taking place? How do you enforce it? In my experience, requiring code review before landing the patch in the main branch is the only thing that makes it happen finally.
Yeah, so I think there's a couple ways to look at the non-blocking part. Like one is you can either review the code after it lands in the main branch or before. I prefer systems where you do it after it lands in the main branch, but GitHub's not particularly optimized for that. And I think GitHub's code review tools are so good that it's probably worth just kind of going with their workflow, which is reviewing it before it lands in the master branch. The main thing I was saying with non-blocking is, people can open a pull request, and they can early on in their cycle, they can continue to add to it. And when they reach a point where they're kind of finished with that pull request, they can go on to something else and don't feel like they have to wait for somebody to review the code. In terms of actually getting the reviews done, there's no perfect science like anything else. I think a lot of times blocking off time at the beginning of the day, so right after maybe if you do like a stand-up, during stand-up, you can talk about, I have this pull request. It could use a set of eyes. People can say, well, I've worked in that code recently. I could probably help with that. And then just going and having people doing them kind of as the first thing in their morning, and then moving on to other work.
Up the back.
So you said that, in a session of Teamfactoring, if you, don't have something to ship within an hour.
Yep.
You said you should toss it. Does it mean literally throwing out the code?
Yes, literally throw out the code, git reset -- hard. And then the reason for that is, I didn't go into too much detail. The reason for that is, when I first started doing those sessions, at the end we didn't do that, and what would happen is, this thing just became this like amorphous refactoring project. Like, we half finished the refactoring. Like, is Joe just gonna like finish that like tomorrow? And it could go on for 1 day, 2 days, that kind of thing. When we realized that all the value was in the discussions between the programmers during the session, then we just started git reset -- hard at the end. But a couple of times we've actually gone and refactored the same piece of code in multiple weeks in succession. And the first time we might only get through like 30%. The second time we get through 80%. Like a third time we actually were able to do it quickly enough to have something that we're ready to ship the third time we approach it. So it's kind of like a kata in that form.
Cool, thanks.
Hi. What's your opinion about the code freeze in terms of not adding new functionality to your application for a while because you want to achieve that quality that you are expecting because you need to do that big refactor that your application is needed.
Yeah, are you saying like basically dedicating time for refactoring?
Yeah, is it a better way? Do you think it's a better way when you need to do a set of changes that's so big that you cannot achieve it in small steps?
Yeah, so I think that a lot of the prevailing wisdom on this, which I still subscribe to, is that it's not desirable to block off time for refactoring for reasons that are pretty obvious, especially the impact that has on the business. You got somebody who's non-technical basically can't see the progress, although with static analysis you can do some work to try to expose that to the non-technical people. I know that there are folks who have sort of evolved their thinking on that. I think Michael Feathers more recently has been advocating in some cases to help projects actually dedicating time for refactoring as a way in serious situations to be able to salvage a code base. Because maybe your only other option is to toss it out and rewrite it, which isn't much better. So I tend to prefer, though, kind of weaving the refactoring process in your day-to-day work. And never having that conversation to say, oh, we need time for refactoring. Refactoring is just like coding, is just like typing, it's just like all of these are activities that you do, but you don't actually go to your product manager and say, hey, I'd like to allocate some time to thinking about how to solve this, right? That wouldn't make sense. So I would consider refactoring in the same boat, and you just kind of keep going as you go.
Thanks. Gentleman there.
Yeah.
All of these techniques are great if you've got coworkers, but if you haven't got coworkers, have you got any suggestions aside from using CodeClimate?
Yeah, so there's a website called pairprogrammingbot.com, which I really like, and it basically just presents you one question at a time. And the first question is, do you have a test? And you say like yes. It says, okay, does the test fail? You say yes. It's like, okay, now write code to make the test pass. And then you click a button that says it passes, and it says, okay, write another test or refactor. Or it says, does it need to be refactored? And then you can either refactor it.
Does it ever say, want to play ping pong?
Yeah, right. That would be more accurate. So in terms of working alone, I think the work that Abdi's doing with Pair With Me is a great task. When I was working on CodeClimate alone, I actually had somebody in New York who was also working alone on their company, and we would exchange days, basically. So like he would work on CodeClimate for a day, 1 day every week, and I would work on his project 1 day every week, just so we had somebody to bounce ideas off of, so we wouldn't go insane, pursuing these crazy paths without discussing it with anybody. So that can be one approach. I'm not sure there's a magic bullet there, but I would try to find creative ways to collaborate with people that you might not otherwise.
Thank you.
I like the idea of it's like you're building two businesses at the same time.
Yeah, exactly.
It's always good to know that if yours fails, I'm just going to work on yours.
Just go work with them, yeah.
We got one at the back.
Yes. Do you know the average CodeClimate score across all the projects, and does that score goes up over time?
The average CodeClimate score across all projects, I actually don't know that. It's pretty interesting. One of the most prevalent trends, and this is something I want to do some more data analysis on, is that small projects score well and big projects don't. And I suspect that, and so like gems, for example, tend to be much more likely to have ratings like 4.0 than a Rails application that's been maintained for 2 years and does all this functionality and actually makes someone a bunch of money. And I suspect but I haven't done the analysis yet, that there's a point at which if your project is greater in size or been around for this amount of time, that it's very difficult to actually have high quality code, good static analysis metrics. And that's kind of was the part of the hypothesis that this talk is based on. It's like, okay, if we as a community are running into this problem where we can't have big projects that are also in good shape, then what do we do about that and how can we try to improve on that? And maybe the answer is, it's actually impossible to have a Rails application above X thousand lines of code that is high quality, so you need to move on to services by a certain point. And I'd love to figure out where that is, if that exists, and if so, where it is.
Everyone, please put your hands together for Bryan Helmkamp.
Thank you.